So I'll read it and then I'll be quiet so you can copy. Very little energy makes it from one group of organisms to the organisms that eat them. Energy is lost as heat. And only about 10% of all the energy that plants capture from the sun is captured by the animals that eat them. So 90% is lost. 90% of the energy. So 90% of the calories in your wheat, if you feed them to the cow and then eat the cow, you're only getting back a short amount of them. You okay? Yep. So very, very little energy makes it. Yeah, just go ahead and turn it in. Yeah. I'll tell you what, I'll give you a little bit of time if you want to finish number 4. Just number 4, that's out of your own head. So that'll be, how has your thinking changed based on our discussion?
You said we could do whatever back.
Yeah, that's fine. That's fine. And you guys did a fantastic job on that because you were really thinking hard, and that's good. Some of you were quite passionate about it. We have a few people here who are born survivors, I think. Okay, we'll finish when we come back. If 10 million calories of sunlight pour over an area, the plants there can capture about a million of those calories. The rest is lost as heat, and in the case of the sun, also as light. So 10,000 calories can be captured by the herbivore. 90,000 calories just go out into the environment as heat. They just go to run the rabbit's body. So when old coyote comes along and eats that delicious rabbit, how many calories out of that does the coyote get? Coyote! Whoops, I forgot to record for a couple slides. So yeah, that mountain lion, when it eats the coyote, is not getting a lot of calories. Now, when the mountain lion dies, what will consume it? Detritivores and special detritivores called decomposers. So if that mountain lion keels over from old age or falls off a cliff and its skull is bashed in by a rock, turkey vultures and crows are going to come pick at its bones. Earthworms are going to eat the bits of stuff that fall off of it. Maggots are going to eat its flesh. It's after lunch, right? This is good. It will be broken down. How many calories for every 100 it took in, how many calories will be available to the next level? About 10 calories. About a tenth. 90% of the calories that it took in are just lost out into space. 90% of the calories you take in any day are just lost. Only about 10% of those, if some other species was to come along and eat you for lunch, which fortunately we live in a time and place where there aren't a whole lot of things that are preying on humans for food. I'm happy about that. Only about 10% of the calories that you've taken in would be available to the next level. Of 100 calories are captured by that top consumer, that mountain lion. The rest is just lost. What percentage of the original calories are we talking about that makes it all the way up? This is sometimes called a trophic pyramid. We're going to draw it. So we started off with 10 million. And out of that, we got, actually we skipped a step, didn't we? It should have been 1 million to 100,000. So if you had to decide what you were gonna eat, what's your best option? Eat the sun. Yeah, your best option is to develop chloroplasts and become a producer yourself and be able to turn sunlight directly into food. But being as that you probably can't do that, now of course humans, here's the other catch. Humans can't eat grass and get calories out of it. Grass has got a lot of cellulose. It's like eating trees. We can't eat a tree and get nutrition out of it. Our gut can't break that down. Now, we can eat corn and wheat and tomatoes and peppers and zucchini, and there are lots of plant foods we can eat. You know, so this could be 100,000 calories of any plant, but we can't, you know, there are foods we can't eat. You can't eat blackberry bushes. You can eat the blackberries, you can't eat the bushes, you can't eat the stems and the leaves and the thorns. You can't do it. So there are limits to what an individual organism can eat.
Yeah.
Okay. There's a large biomass of plants in any given ecosystem. In terms of actual numbers of individuals, we have a smaller number of herbivores. What else do we call herbivores? Primary consumers. They are the first consumers. This is part of the notes. We have a...
Are we drawing this?
Yeah. Yeah, we have a slightly smaller number of what's the next step? Well, yeah, carnivores, omnivores. Both carnivores and omnivores are going to function here. Secondary consumers. And I'll make a line here that this is both carnivores and omnivores. And then when we get up to the very top level, when we get up to the top of any given food chain, we have yet again a smaller number. These are often called top consumers. Okay, that's the smallest number of individuals there is. Why? So jot down your explanation for this. Literally write an explanation in your notes for why we see this pattern.